Online students, check out, guys. Online people. Is it clear, my voice? Online students. Okay, right. What is our last one? Huh? The basic two rules, no? Huh? Yes. Okay. Okay. So what we said here after relationship, okay, verify it. One is we called as what? No? Insertion rule, and one is deletion rule. These are the two rules we have here. Okay. Insertion means what we said, we cannot insert unreferenced values, the values which not or which is not existing in a memory key. So whatever the values are there in the primary key that we can insert. But it is not there that we cannot insert. So then child, okay, poor, but unfortunate. This cascade rules are how to address child before dating a from parent table, because I said to you, so we cannot address to child. So now how I can address means, so there are two rules are there. Cascade rules, on delete cascade, on delete a set null. Okay, na? With the help of these two rules, I will be addressed to my child before deleting. What it will let you right now take this continuation. Distinct transits. Open, open. Door open చేయ right. Okay. These are the two cascade rules we called. Okay, now, and in this, if I'm using on delete cascade rule, what it was happen here when we delete a row from parent table, then the corresponding child rows also deleted from child table. Okay, now the corresponding child rows also deleted from child table automatically happen. So that means no parent, no child. Okay, now this is what on delete cascade is tell us. Okay. Now how I can apply this cascade rules here? Observe careful. And these cascade rules are you should apply only child table because to whom I need to address, we are addressing to whom? Child. So that's why these cascade rules also apply on child only. Okay, na? Not on parents. Okay. Let you come. So how to use this? Okay. Come to your database now and connect with your user ID and password. Okay. Let you see this. What is my previous tables here I design now? Okay. This is our previous example. So the same example I'm just taking now and doing some modifications. Okay, now you can see first as usual, your course one and primary key, course ID, course name and fee, and a few course details are insert. So now I'm inserting course details. And here it is not changing anything as usual you can. But coming back to child table, student one, student ID, primary key, student name, and course ID number references course ID of course ID. Up to here, same. But okay, we are taking reference from course one. Okay. Lastly, that means on your references column. Okay. On that column, you can apply what now on, and later you can go to insert few records now. Okay. This okay now. Let you come out and check here one by one. So first, I just go to here to prepare your table is created successfully, and later I want to input some course details here. Okay, first record, and next I have to go my second record. Okay, and next I have to go here child table. I'm going to take now, but before that I just make it commute here to permanently save and see final. So table successfully created, and whatever the things you can insert your. So first child information, and I'm going to second child. Okay. So okay, fine. So I committed. So finally, let you come out and see this, guys. Now the two okay tables we designed. The first one we called select a star from course one. It's my parent table, and next we have what now student one. So the two parents, and each parent is having individual one child. Oracle is having one child, Java is having one child. But this time you can see. Now I'm going to, I don't want to go to child table delete first, then after come to parent delete. Yes or no, not necessary. So simply you can call delete from. What is a parent table? Course one, where the course ID, for example, I'm giving now 1001, for example. So now I did. See, now it is accepted. But previously, when I tried this, what happened? It's showing error. The previously I tried this, but it was showing to me error. But now it was successfully accepted. Okay. So now after that, what you finally understand here, see your parent deleted, When parent is deleted, automatically child also deleted. So this is, and not only one child. Suppose you have a one parent table course one. This course one references are you taking into how many number of tables, that all tables child are deleted. Understand now? Once parent is deleted, that parent referential identity was how many tables it was, that all tables child data deleted along with the parent. This is on delete cascade advantage. Okay, na? So if you, I said yesterday, suppose your table having relation with the 20 child tables. So in 20 child table, one parent table. So now if I want to delete my data from parent table, what should I have to do? First, this 20 child table referential data delete. It was very headache to the real-time programmers in companies. So that's why I don't want to go like this. So simply, if I'm using on delete cascade at the time of relationships, what is the advantage to me when I want to delete any parent references? Parent references are having in how many number of child tables, all child can see with only one single query statement, complete parent and complete childs are deleted. Here I don't want to write 20 queries, 20 tables. I don't want to write. Okay. From parent table delete, you are choosing. Yes, right. And this is for my testing. I will take now. So I can say now it is allowed. Now take example after definition. Okay, right. This is on delete cascade when we want to use on child table at the time of relationships established. And this is one advantage to you. Okay, now you can delete parent as well as child. But next, one more rule is there. What is this? On delete set null. On delete set null, what it was tell us here, we are deleting. So child data, I don't want to delete. I want to delete only parents' data. So instead of deleting child information, it just make it as what no null. That in the value, what we have the reference of parent, the reference of parent value will make it as null. So when you want it like this, then you can apply what no on delete set null. But remember, on delete set null, on delete cascade, you should not apply on the same table. Okay, na? Any one only can apply. Both combination you never. Okay. So now definition write on first. So on delete cascade. Sorry, on delete set null. So when we delete arrow from parent table, then the correspond converting into nulls in a child table automatically. Okay, now let you see this. Okay, the same example, just take it out. Now the course number 2, remaining all are same. Just I want to change my table name. And your student number 2, taking references from 2 on delete set null. On delete set null. And again, same as you just go to do your operation 2 and course ID 2. Okay. Let you come out and check your again the information about your the first table courses. And now to come back and put it here. So first table is created, and as usual to input your required row information. And the second row is same as. Okay, I just to commit. And the next one, the child table along with your on deleter set null. And I have to go ahead here to come back now and input some child informations. Okay, the first child and coming to the next second child. Okay, so here also I just committed to call your 2 tables now, the course number 2 and same as a student 2. Student 2. Okay, fine. And now we can see your delete operation now. So delete from what is my parent table? Course 2, where course ID is equals to 1001. So deleted success, but coming back to your parent table is deleted, but child table information you can see not deleted, but the child referential parent reference identity automatically making null. Okay, no, but parent is deleted. Okay, but the child was making null. So null means what we discuss orphan child. Orphan child means a parent is there, but who is this? We don't know. Okay, no? So now here only one parent is available. In the future, if I want to change this, I can change with which number? 1002 only possible. Okay, no? Right, Amul. Okay, right. So these are on delete cascade and on delete set nulls. Okay, no? To when we want to make the relationships, these two special cascade rules also apply. Then it was very easy for you to deleting parents' data. Okay, no? Right. Now the next level, observe. Sir, as of now, we applied unique constant, not null, check, primary, foreign, yes or no. So five constants, sir, we applied. But sir, suppose are you designing, suppose this relationship are you designing or some tables you're designing along with your constraints, integrity rules. After designing your tables, these tables you are submitted to your client. So suppose you are a developer, you design table with perfectly with validations, everything you applied on the table, and you submit it to me. I'm your client. So if you submit to me, then as a client, definitely I have to check no, yes or no. Ah, so then you are giving this table, for example. Are you giving this table to me? Okay, no. But as a client, I want to know on this table, there are three columns are there. On these three columns, is there any column is having constants or not? Otherwise, my developer was applied any constant on this table or not. That information I want to know as a client. Yes or no? You're just submitted. But submitted after, I want to check whether constants are applied or not applied. Okay? I want to check that. So how I knows my developer was applied constants on this table structure? How I knows? That is one thing. Okay, na? And next one is what now? Suppose you applied constants on my table structure. My table required columns are the different conditions, different constants are you applied. But again, I have to know on which column, which type of constraint are you applied. So CID, which constant you applied? Unique constant, primary key, not null, check, foreign key, default, what you applied. That I want to know. Next, next course name. Is there any constant applied? If you applied, then which type of constant are you applied? Next, fee column. Fee column you applied constant or not. Suppose you applied, then which constant you applied. So how I know, sir, how I want to see my constants details, which you applied on a table structure. That is practically, I want to see it. I want to view it. Okay. Whether on this table constants are there or not there. If it is there, then which type of constant on so and so column we applied. So the complete internal information as a client, I want to see. Then how in industry people, even you also, when you're working in your work premises, okay, in a companies, suppose you want to also know it, on this table constant is there or not there, which constant I was applied. So that kind of information do you want to see it, then there is a one concept we have here. That concept is called as a data, right on data dictionaries. Data dictionaries, or else we called as read-only tables. Data dictionaries, or else we called as read-only tables. Okay. Now we can carefully observe what is data dictionary and why we called a read-only tables and what kind of information is storing under these tables. Okay, na? First of all, carefully remember data dictionaries are called as it is a system defined tables or predefined tables we called first point. These are we are not created. These are system defined tables. And these tables, when it will create by system means at the time of your Oracle software installation time. So whenever you want to installing your Oracle software, along with software installation, internally some predefined tables are created by your system. And those tables, what it was created by system, the system defined tables are called as what now? Data dictionaries. So that means data dictionaries are, it's nothing but it is a table. It's a system defined tables. And these tables, what we have here, in these tables, so it is a table means compulsory we are storing some information. Then what kind of informations are stored in these data dictionary tables? It means that whatever you applied, whatever you did in your database, that every facility of information will store. For example, are you created one table? Are you created one table? Okay, na? Suppose in your database, are you created one table? Okay, na? Right. So now are you design one table? Okay. On this table, what kind of things you applied? Suppose if I was, okay, I was applied your constants. Okay, I applied constants. Then these constants details, which constant, on which column, what you apply, everything, details describing. So your all constants details which you applied on the table, those constant details are storing into one data dictionary table. Because data dictionary is not only one, two, it's a so many. Okay, so DD1, one data dictionary. DD1 data dictionary is saving what it was saving, constant details are saving. And which constant? The constant which you applied on your table. So the details are, it will be saved. Suppose the next level, are you applied on this table? Are you applied on this table views? Suppose you created some views on this table. Then these views information will save under another data dictionary too. Like you applied on this table, for example, indexes. You applied indexes. Then indexes information saved into another data dictionary table. So like you applied on this table, for example, clusters. Then clusters information will save into another data dictionary. So if you applied on this sequences, that sequences information will save into another data dictionary. So that means which kind of facilities we applied on the table structure, that every facility information will save into the relevant data dictionaries. So that means you have imagine in database we have the thousands of data dictionaries are available, and every data dictionary will save that particular relevant information. Constants, constant data dictionary save. Views, view data dictionary store. Synonyms, synonym data dictionaries will be saved. Okay, na? In this way, it will be maintained. And these are the information what I said here. This information, what we are storing, constant, views, sequence, what we applied on the table, every information I said save now. And this information we called as a metadata, we called. Which data? Metadata. Data on data is called as a metadata. So table is a data. On the table data, what you applied, that every information internally storing by Oracle server. Based on that only, the programmers, developers, your clients, your company people, they will know it, they will understand it. On this table, what kind of facilities are we are applying. That kind of knowledge, information, awareness, how the in real time programmers will know Means that with the help of what? No, data dictionaries. So data dictionaries will say metadata. Your metadata information of the system or of the table of the database will save under data dictionaries. Okay, na? So like so many data dictionaries we have here. But these data dictionaries, what we have here, on these data dictionary tables, that means system defined tables, I cannot perform DML operations. Suppose these are already system defined, but on the table, my wish, I can insert, I can update, I can delete means not working. Okay, na? So these tables are not allowed DML operations. That's why these tables are called as what now? Read only tables. Okay, you can't write. Write means what? Insert, update, delete. These are called write operations in database. Okay, so suppose tomorrow if you go to interviews, interview people are asking to you, okay, what are the write operations in database? What is the read operation in database means? Write operations are nothing but what now? DML operations. DML operations we called as a write operation. Don't confuse. Okay, na? So what is a read operation? Read operation only one operation. What? Select reading purpose. Okay, na? So, but your data dictionaries are not supporting DML. You cannot perform. But I can perform select command. I can see my data retrieval purpose. Okay, na? So that's why it is called as a read only. Okay, na? Now we can see, suppose, let's come out. If you want to see your data dictionaries, then all data dictionaries of, okay, of your Oracle is having in one table that is called a dic. So dic is called as a main dictionary. So in this main dictionary, your all dictionaries informations will be saved. So now I can enter, see what happened now. Okay. So almost how many are there? 1000 plus data dictionary. These are all are called data dictionaries. Names you can see. SQL Monitor, SQL Plan, yes or no? Okay, Advisor, Progress, current SQL plans, everything. See now this is what? What is this? The main dictionary. So like so many are there. These are all. See, if you want to see your tables, user underscore tables data dictionary is there. Tabs. Okay, tab columns, user underscore synonym information, sequence, jobs, indexes. Okay, na catalog, clusters. Okay, so many, like so many are SQL monitors, plans, everything. Like so many data. These are all are called as what now? Data dictionaries. These are all are system defined, but not user defined. Okay, now, now like so many, we have the data dictionaries in our Oracle, and every data dictionary of table will save some metadata of the relevant object. Okay, now, right on below. So the information means metadata, data on data in the bracket. Okay, na? Your data dictionaries are storing like tables, constants, views, sequence, all. Whatever you applied, every object information will saved by Oracle. And that information in the future, if you want to see, you can see it. Okay, so to view all data dictionaries, then this syntax will be follow. Select a star from dict. And here dict means what now? Dictionary. Okay. Now we can say these are the so many dictionaries we have here. So concepts wise, I will show you one by one. You can understand it. Okay, now right. Now, can you remember previously when we are going to applying constraint on particular column and that constant relevant exception is sorry called a error when it was occurred, what it was happening here in those errors, anybody identify one number is going to showing us. Just a moment. Yes, what is this? sys underscore C008644. What I said here, this is called a constant ID number. And this constant ID, internally, your Oracle is going to be created. For what purpose? Identifying this constant is which type of constant. So this number who understand, Oracle understand, because Oracle is created, Oracle understand. And based on this ID number, Oracle identified this is a check constant, this is a primary key constant, this is a unique constant. So system can understand this language and this ID number. Based on this ID number, the relevant check or relevant constant will be activated, fired, integrate, violated. Understand now? Ah. But sir, this number, do you know, human being can understand? Suppose this number is there. This number, by seeing of this number, can I tell here, can I assume here, can I imagine here, this is a unique constant, this is a primary key, this is a foreign key, default, check, not null. As a human beings, can I understand? No, you cannot understand. So that means same thing. If you you applied your constants on your table in a predefined manner and submitting to client, client also cannot understand. Then client, what he was expected? User understandable format, constant IDs are create. And based on that user understandable format ID basis, client understand that, okay, this is a check constant applied on so and so column by my programmer in this table. They can understanding human beings. So that means what you understand, instead of system defined constant ID, what do you want to do? We want to create a user defined constant IDs. Okay, how to create? Let you come right down below. So first of all, predefined constant, observe now. Text heading. Predefined constant name or ID. Below write down. So whenever we apply constraint on a column, internally system is created a unique identification address or ID. A unique identification address or ID on constraint, on each constraint for identifying for identifying the type of constraint, identifying the type of constraint by Oracle. Okay, now? Now see one small example for you can check. Suppose, are you designed like this? So carefully observe. I just call my tab. Test number, how much here the test number 4. Okay, no? 4, test number 4. Okay. Now you can come back. So don't write. First concept understand. Are you created like this? Your client requirement basis, you created like this. Test number 5, for example. You applied serial number. So number of 3. You applied what now? Primary key, for example. Okay. Suppose you taken here, for example, city. Okay. Varchar 2 of some size. On this city, suppose you applied which constant? Check. So check of what do you say? City is equals to what is this? Hyderabad, for example. That is a condition I'm giving now. That means only Hyderabad is accepted. Other cities are not accepted. So some condition I want to apply. I applied here. And now you can see this. When you apply here, it is a direct constant. Yes or no? It's a predefined constant names. So these constants are directly I'm applying on my required columns at the time of designing levels. Okay, I applied. My table successfully created. After that, what I'm saying here, these tables are you submitted to your client. Okay, now. So the client want to know what type of constants are you applied. How he knows? With the help of data dictionaries. So it is these constant information where it was means under data dictionaries, your oracle is saved. Which data dictionary? That is also good idea. As a programmer, you should know. Okay, na? So my constant details are storing under one data dictionary. The data dictionary name is called as a user underscore cons underscore. What is that? Cons underscore columns. This is my data dictionary table name. So now it is a table. Table means what now? It is a collection of rows and columns. So how I want to, which columns, in which column my constant data is saved. That information I have to know first of all. That's why what I'm going to say, whenever you want to see your metadata of a particular facility on the table, first the data dictionary table structure, first see it. If you see the structure, you will get some idea. What is the idea? In this table, these are the columns. In these columns, which column of data do you want to see as per your requirement? That column you can call. Got it my point now? That's why go ahead. First data dictionary structures you can see. Now the structure was taken. Okay, this is your structure. What is this? Column name, null, type. So it is the same table structure. So what is the column names I have here? Warner. Constant name, table name, column name, position. Then how many columns in this table? In this data dictionary table, how many columns? 5 columns are there. Then what do you want to see? I want to see constant name. Which constant you applied? Constant name, on which column you applied, and in the which table. I have to see that information. So then you're getting some idea. Then based on this structure, what I want to see? I want to see my column name. Column name saving under which column? Column underscore name column. Our column names are saved. Comma. What next I have to see? Constant underscore name. So you have to see which type of constant is applied. Okay, column name, comma, constant name. These are the 2 columns I'm retrieving from which table? User underscore cons underscore columns. It's a select command. Okay, na? Select column name, comma, constant name from user underscore cons underscore columns. These 2 are what now? These 2 are what? Column names. How my column names are there? Na? EID, e-name, salary. Yes or no? These are also same just like that. Okay. So if I leave like this, what it was happening, it will be showing in your database how many tables are there, on each table, what kind of constant you applied, every information will be show you. So I don't want it all tables because I will get a confusion. I want to see a particular table constants details. Got it? Huh? Then particular, specific. Specific means which condition? Where? Now, what do you want to say? Table name, because table name also there here. See, my table name save under table name column. So table name is equals to, what is your table name? Test number 5. 5 or 4? 5. Okay, now let's see. Suppose I am a client, you are a developer, you was designed this table and hand over to me. Now I want to check myself on this table what kind of constants are you applied. So now I'm going to checking like this. Execute now here. Yes. Okay. So now we can see column name. What is the column name? City. What is the column name? Serial number. But can you see this city column? Okay, constant name also there. What is your constant name? SYS underscore C008360. And this is my serial number column. Here also you applied constant. What is your constant name? SYS underscore C008361. So that means these constant names are created by myself or system. System. Okay, you designing like this, you applying like this, your hand over to me, I will see like this. But sir, when I see your constant names in this number format, as a human being of your client constraint, I don't know. So this is called as what? Predefined constant names. And who understand this? System understand. System no. 8360 means what? System no. But I don't know. Because that is a system language. That's why system can understand. But human beings cannot understand it. So that's why in real time, don't apply constants on your table structures in such a way. Don't apply. Your clients are not allowed. Okay, na? In real time, if you directly go to apply your constant on your column means your clients are not allowed to you. Immediately rejected your tables. Then you are saying that, sir, what now? Everything I checked now, then still why are you not accepting my client? Okay, na? Because of reason is what now? Client cannot understand. That's why client will not taking your tables. Then what should you want to do? Constants are apply on a table in user understandable format. Okay, na? As of now, what we applied like this in real understandable format, you need to apply. How to apply? Let's see. Right down below. First, take this one. Mm. Take one example. This predefined constraint name. Below take note point. If we want to view constant name along with column name of of particular of a particular table in Oracle database, then we should use a data dictionary. A data dictionary is is what is a data dictionary? User underscore cons underscore columns. So every data dictionary, first you have to go ahead and check your what structure. When you see the structure, you will get some idea based on that knowledge. You can call whatever you want it. And which information do you want to see that you can call it. Now, this is predefined constant ID is our name. So now we will design our user understandable. Right. How to create user defined constant name or ID. Right. when we create our own constant name for identifying, for identify a constant, for identifying the type of constant, otherwise the type of constant on a table is called as user defined constant, is called as user defined constant. Okay, and here some syntax was there. So the syntax what's let you say. As usual, your column name and column name after immediately data type. If it is required size. Okay, then after you can use this keyword constant predefined key. Then after user defined constant name. Then after you can give constant type. Okay, na? This is our syntax. Then after constant type. Right. Constant type. Okay, na? This is your user defined constant, sir. How to apply and create it. Okay, when you create like this, it's your wish, and the name definitely user understandable format only our names can be preparing. Okay, let's see the same example. Suppose I just go to the here. Okay, create. Don't write first observe. Test number 6. The same serial number, okay. Number data type, if you want its size, you can. But previously, what we did, directly we applied a constant type. But now, not like this. First, you have to take constant predefined key, primary key, shortcut PK, understandable. This primary key constant applying on serial number. In real time, same as it is, the people will create it. Okay, now if you go to real time, you also create like this. So shortcut PK underscore serial number. So when you create your constant name like this, so now if you send to client can easily understand. Oh, my developer is applied a primary key constant on which column? Serial number. It was very clearance. Okay, na? Then after what next? Primary key. This is called a type of the constant. Okay, na? Comma over. Second one is what now? For example, what? Size. Here also same na? Constant. STRAIN. Okay, na? Constant. Now what is that here? City. Which city? And then after you can apply check. What do you say? City is equals to, for example, Pune. Okay. Now, is it clear? Huh? Now you can see to execute this one. Table success. Then after call your data dictionary. What is my table name now? Test number 6 and execute now. And see, now it was very clear. Column name, city, constant name, CHK underscore city. And this is serial number, PK underscore S number. So now when you design your table or you applied your constant like this and send to, okay, your client, na, the client easily can understand it. Okay, na? Right. Take back seat, some chair, take back seat. Freely move your legs. Okay. Mm. Now take exam. Okay. So that means constants, how to practice, no? Don't practice in first level. Practice this one. When you are trying, when you're doing some lab exercises or practice, try to habit like this. Okay, na? Then it will be remembering easily in real time. Also, you can easily making like this. Okay, now don't directly apply constant. Okay, so from now onwards, you can practice like this. Okay, complete. Mm. Okay. And now see here. These are, we are applying constant. How it was applied means along with table creation we applied as of now. Either predefined or user defined in any method, how to apply it along with the table creations. But the next level is what now? We are not applying constants like this. Suppose one normal table created already, one table already existing. So on that existing table, how to apply constant? Okay, now as of now, how we are applied constant along with the creation. But I don't want it like this. Suppose one table already there in my database. Okay. On that existing table, my client requirement basis, I want to apply constant. Okay. That scenarios we will see tomorrow. Okay. Now, the tomorrow we will go to that kind of scenarios. Yesterday notes uploaded.